All right, we're on page 1 of our Unit 7 packet here. So this is our first lesson in the unit. And what we're looking at here, we're trying to prove what the properties are for a parallelogram. And so we're going to draw on some of our prior knowledge that we have from this semester, last semester, with our congruent and our similar triangles. Okay. So remember, with congruent triangles, we have kind of 5 ways to prove triangles are congruent. We can say their sides are congruent, side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. Those are our 5 triangle congruencies. We're going to use those today to figure out some of the properties for this shape we call a parallelogram. We have our parallelogram down here. Okay. So first thing we might want to do before we look at a parallelogram is write down our definition. You should have this, or will get this into your toolkit as well eventually. So the definition of a parallelogram, it is a quadrilateral. So that means it is a 4-sided shape with opposite parallel sides. So we are going to use that to help us figure out a property of the parallelogram, which is that the opposite sides and angles are congruent. Okay, so we're going to go through this flow chart here together. So we have this we'll say a parallelogram, Walt. So we have a family of quadrilaterals. Walt is like the grandfather of the quadrilaterals. What we're going to do is we're going to add our parallel line symbols to the diagram. And we're going to draw in a diagonal from W to L. So I know that this is a parallelogram. I'm going to put my given information kind of in this first box here. So we can say Walt is a parallelogram with diagonal WL. Okay, so that's our given information. And we just wrote down the definition of what it means to be a parallelogram is that we have opposite sides that are parallel. So that's why we can add our parallel symbols to our diagram. So add our parallel symbol WA. And we know that that line WA is going to be parallel to TL, side TL. I'm going to put my parallel symbols here, TL. So those two sides are parallel. We also know that side WT, that's going to be parallel to AL. And the reason these are parallel is because this shape is a parallelogram. That's what it means to be a parallelogram. So I'm going to write here definition of a parallelogram. So the reason for both of these is the same. So you can I'll just connect this line here. Definition of parallelogram would be for both of these, okay? The other part of our given information is that we need to add a line from W to L. That's our diagonal. So let's add a diagonal here. All right. So now we have 2 triangles, essentially. So if we look at our proof here, we are trying to get to the point where we can prove that these 2 triangles are congruent. So we're going to need some congruent angles. We're going to need some congruent sides to do that. Remember, these are 5 triangle congruencies up here. Okay. So first one we'll look at, let's look at our lines, WA and TL. Well, here's WA, here's TL. We can connect them, create that Z shape. Remember that Z shape is our alternate interior angles. I'm going to kind of move this off to the side. Oops, I didn't want to take this one with it. So those 2 lines are parallel, and what that creates are alternate interior angles that are equal. Remember, inside that Z shape. So I have AWL, that's this angle listed here. That would be congruent to TLW. That's this angle here, TLW. Okay. And those are congruent because of the Z shape. We call that alternate interior angles. alternate interior angles theorem. Now our next set of lines here, so we've got another set of parallel lines, WT and AL. So I'm going to highlight WT and AL. So these lines here are parallel. You can connect them, make our Z shape there. And then we should have another set of angles that would be equal to each other. It's the angles inside that Z shape. So I'm going to put little angle marks here. And then on the diagram, I'm going to put 2 markings to differentiate it from the ones I already labeled here. So I'm going to call that, we've got TWL, that's this one. That is going to be congruent to ALW. And that is for the same reason. They are also alternate interior angles. And notice how like these lines being parallel created these alternate interior angles. These parallel lines created these alternate interior angles being congruent. So make sure we kind of look in that diagram. It should be flowing from the right piece of information to the next piece of information, okay? Now, the other thing we have here is that WL, that is congruent to, well, let's look where WL is. WL is this line here. Well, that is actually the same exact side or same exact line in both of those triangles. So I would say that it's congruent to itself. So I'm going to add a little mark of congruency here. So WL is congruent to itself. Remember, that is like what we see in the mirror, that we call that the reflexive property. Reflexive. So now we should be able to say that these triangles are congruent to each other. And the reason that they're congruent, well, I know that this right here, this is an angle statement. This is an angle statement. This is a side statement. So it's got to be one of these two, angle, side, angle, or angle, angle, side. So if I trace the side, that's equal. And I trace the angles that are also congruent, we would want to know, okay, well, is that side kind of in the middle of that or not in the middle? So if you notice, both of those angle marks, they actually connect to the sides. That means it's in between or in the middle. So this would actually be angle, side being in the middle. So these two triangles are congruent because of angle, side, angle. And I could label that, we have AWL, that would be triangle TLW. And that's because of angle, side, angle property or congruency. Okay. And then for our last part here, well, what we were actually trying to prove, we weren't trying to prove that the triangles are congruent. Like, that's not our end goal. What our end goal was to prove is that the opposite sides and angles are congruent. That's one of the properties. Okay. So now that we know these triangles are congruent, well, I've got WA, that should be congruent to LT. So WA should be congruent to LT. If we look at these triangle statements, if the triangles are congruent, then their parts are equal as well. I also would know, so I can say and, I would say here WT, WT would be congruent to LA. So I'll put 1 mark on those. Okay, and now the reason for that is, well, if these triangles are equal, not only are these 3 parts that we've already identified the same, the rest of the parts are also equal. We call that CPCTC. Remember, corresponding parts of congruent triangles are congruent. And let me actually draw this, the diagonal in here, because we technically still have these are 2 separate triangles here. I just forgot the diagonal. Then what we also have is angle A. So angle A in this triangle would be, if it's the first letter, angle T is the first letter. It would be congruent to angle T. That's for the same reason. Corresponding parts of congruent triangles are congruent. So we have now proven what we set out to prove, that the opposite sides and angles are congruent. That is one of the properties. So we could say a property of a parallelogram is that it has congruent, or we'll say congruent opposite sides and angles. Okay. So just so you know, in this diagram here, we could have also, if we wanted to, we could have started with a different diagonal. It could have been this one. And then we would have proven W and L are congruent, but we don't have that here in the diagram because technically angle W is being cut by this diagonal here, and it's not necessarily cut in half. So just keep that in mind. So that's why we only put angle T and A in this diagram, but technically angle W and L would be congruent, but we're not going to create a whole new proof just for that. Okay. So now what you're looking at, that is one property of a parallelogram. Opposite sides are congruent, opposite angles are congruent. Now what you're going to try independently is on page 2 here, you are proving one of the other properties to a parallelogram. And we want to prove that the diagonals of a parallelogram bisect each other. Remember that word bisect. I would look in your toolkit. What does that word bisect mean? So I would maybe have a definition here next to that. And then what you're going to do is you're going to go through the flow chart here, and then you're going to add your verbal written explanation for that in a what we call paragraph proof.